In this video, we present our work, Large-Scale Multi-Character Interaction Synthesis. We focus on interaction for more than two characters and their interactions are coordinated automatically. Previous methods for single-character synthesis do not consider the interaction between characters. As for interaction synthesis field, previous optimization-based methods rely on manually designed objective function that may not generalize well. Previous deep learning-based interaction synthesis mainly focus on two characters. While previous crowd simulation methods consider more than two characters, their interactions are sparse and passive. We identify two challenges on multi-character interaction synthesis. The first one is the lack of data. Existing interaction datasets are mainly collected for two characters. While some crowd dataset involves multiple characters, their interactions are sparse. The second challenge is the transition planning with dense and close interactions. Scheduling suitable transitions for multiple characters is highly restricted in both spatial and temporal domains. To solve the aforementioned challenges, we propose our generative method for multi-character interaction synthesis, including a coordinatable interaction space and a transition planning network. The interaction space solves the generation of multi-character interactions by following divide and conquer idea without requiring the multi-character dataset. The transition planning network provides coordination as the condition for the generation process. Specifically, we divide multiple characters into many social groups of two characters that can be modeled with a pre-trained diffusion model. We auto-regressively apply the diffusion model to take observed motion clips of a social group as input and to synthesize a social group by conditioning on the previously generated groups. The condition is facilitated by the classifier guidance on smoothness and hip distances between the group to be synthesized and existing groups. To solve the second challenge of transition planning for dense and close interactions among multiple characters, we propose a planning network to predict high-level orders based on the current interaction observations. The design transition is represented as the regrouping of social groups. Considering the lack of data, we propose to train our planning network in a reinforcement learning framework. The planning network is the policy network and the transition plan is the action. Our coordinatable interaction space is the environment to produce natural character interactions. We designed the reward function to be the smoothness and action diversity. Transition begins. 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 We gradually add new characters to existing multiple characters. By adding new characters, we increase the number of characters and our method can generate interactions although it is only trained on a two-character dataset. Another example of adding new characters. Let's follow the purple character. Transit to first interaction. Transit to another. Transit to dance alone. Another example. The two are coordinated to interact. Planning transitions with dense and close interactions. Another example for many characters. Let's follow one character. Planning transitions with dense and close interactions. Transit to an interaction. For even more characters. As there is no existing method, we build two baselines for comparison. As we also use intergen, we compare with it without changes. We also implement an adaptation to intergen where we integrate our coordinatable interaction space into it. We call it intergen dagger. Intergen synthesizes heavily overlapped characters. Characters from intergen dagger are not smooth due to the lack of transition planning. Ours can generate better multiple characters interactions with coordinatable interaction space and transition planning.